Okay, so at this point you should have seen the 3 videos on how to add binary numbers, how to subtract binary numbers, and how to multiply binary numbers. And now you are ready to learn how to divide binary numbers. Now, before I show you how to divide binary numbers, I need to show you a bit more about the trick I showed you earlier. Remember that when you have any binary number, like let's say 6, if you want to multiply that number times 2, you just simply add a 0, and now 6 has become 12. Well, if we add another 0, we have multiplied 12 times 2 to get 24. And if we add another 0, we will multiply that times 2, and so on. So let's look at this another way. If you add 1 0, you have multiplied it times 2. If you add 2 zeros, you have multiplied it times 4. And if you add 3 zeros, you have multiplied it times 8. So again, it's going to go 2, 4, 8, 16, and so on. So this is important for you to remember when you're looking at how to do division, and I'll show you why in just a minute. Okay, so let's start with a very easy division problem. Let's say we're going to divide 4 by 2. So how many times does 2 go into 4? Alright, so we already know the answer has to be 2, but let's see how we arrive at that answer. Let's imagine that the answer was 1. If the answer was 1, then the number in here would have to be 2, because 2 goes into itself 1 time. So we know that that's not right. We know that 1 times 2 is 2, and we can do better than that. So let's go ahead and move 1 digit over and consider what if the answer was 2. Well, if the answer was 2, then we would say that 2 times 2 is 4, and in fact we have the right answer. That's one way that you can do this. Here's another way. If you consider 2 into 2 right here, you could say that it goes 1 time and then just simply bring up the 0 and then test it, and you'll see that you are correct. 2 times 2 is 4. So that's a very simple example which just gets your feet wet on how to do this sort of problem. So let's look at something a little bit more complex. Okay, so now we are going to consider, let's say, 3 into 9. Okay, so first of all, consider what if the answer was 1. Well, if the answer was 1, then this number would have to be 3, which it's not. So let's instead consider what if the answer was 2. And then the question for you is, what would this number have to be if the answer was 2? Remember that anything multiplied times 2 is basically that number with a 0 at the end, so the number in here would be 0, 1, 1, 0, which is this number with a 0 after it, because that's multiplying this number times 2, and we know that that is not the case. We know that this number is 9, not 6, so we know that the answer is not 2. So let's go ahead and move another digit over. Now, what if we considered that the answer was 4? Then what would this number have to be? And so, remember, if you multiply it times 2, you're adding 1 0. If you multiply it times 4, you're adding 2 zeros. So it would have to be this, which is this number times 2 adds a 0, times 2 again adds a 0, and you get this number. So 3 times 4 is 12, and we know that 12 is not the number here. In fact, it's too large. So we need to not go quite this far. So let's go back one step and consider that we're going to be using the 2. The answer is going to have a 1 in the 2's place, and now we only have to determine what is going to happen in the 1's place. Well, we know that it's not going to be a 0 in the 1's place, because that could only be true if the number in here was 6, was 0, 1, 1, 0, like we looked at. So that only leaves the possibility that this is going to be a 1. And now we can test it. We can multiply. If we wanted to, we could write out this times this, and we would see that we would get the correct answer. Or we can just look at it and know that 3 into 9 is 3. So what we did there is we tried the first digit. If that didn't work, we tried the next digit, and so on. We tried the 1's place, then the 2's place, then the 4's place, until we found our answer. Let's look at another example. Okay, so now let's consider dividing 5 into 10. How do we do that? Well, let's consider, what if the answer was 1? Then what number would be here? Well, the answer is this number would be there. So we know that's not the case, so we can know that the answer is not 1. What if the answer was 2? Well, then what would be inside of here would be this number with a 0 after it, which means it would be 0, 1, 0, 1, 0. And if you look, they are exactly the same, so we can stop right there. We have our answer. We know that 5 into 10 is 2 times. And that's how we do that. Let's look at another example. So let's take a look at 5 into 15. So we have 5 into 15. Now, how do we do this? Well, first of all, let's consider, what if the answer was 1? What number would be in here? Well, it would be this number. So we know that the answer is not 1. What if the answer was 2? What would it be? Well, it would be this number with a 0 after it, because putting a 0 after it multiplies it times 2. And we'll notice that this number is 10, and 10 is less than 15, so we can try the next digit over, although it might be too big, but we can try it. So if we try the next digit over, which is 4, we ask ourselves, what would this number be, or rather, what would this number be if we were to consider that the answer was 4? Well, it would have to be 0, 1, 0, 1, 0, 0, because we're multiplying it times 4. And we immediately can see that that is way too large, and so we know that we don't go all the way over to the 4's place. Our answer is going to be inside the 2 and the 1's place. So what we do is we try the 2's place. We multiply 2 times 5, and we get 10, which is written like so. We can subtract. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 0 is 1. And 1 minus 1 is 0. And you can see here that what we are left with is 5 into 5, which goes 1 time. And there's our answer. We can then see that 5 into 15 goes 3 times. Let's look at one more example. Okay, so now we are going to look at 5 into 25. Now, how do we make 25 in binary? Well, we know that we have the 1's place, the 2's place, the 4 place, the 8 place, and the 16's place. Okay, so if we want 25, we know we're going to have at least 16. And now if we take 25 minus 16, we know that we get 9. So all we have to do now is, with the binary digits we have left, we have to make 9. So 8 and 1 makes 9. And so 16 plus 8 plus 1 makes 25. And so our binary number is 11001 in order to be 25. So we can go ahead and write 25 here, like so. Now we have our division problem set up. We're saying 5 into 25. Now we already know what the answer has to be. It has to be 5. Let's see how it becomes 5. So first of all, we know that the answer is not 1, because if the answer was 1, then the number here would be 0101, because 1 times 0101 would be 0101, so we know that's not it. If the answer was 2, it would be 01010. So we could write that out really quick if we wanted to. And we can ask ourselves, is this number less than this number? And it certainly is. So we should try one more digit over to see if we can get that to work. So if the answer was 4, then the number here would be 010100. Because when you multiply it times 2, you get 1 0. When you multiply it times 4, you get 2 zeros. If we were multiplying it by 8, we'd get 3 zeros, and so on. So now we have to ask ourselves, is this number greater than this number? And the easiest way to do that is to write it underneath. So we can just write 10100, and we can look at it, and if we can subtract, 1 minus 0 is 1, 0 minus 0 is 0, 0 minus 1, well, if we have 0 minus 1, we would borrow, or we would look at the whole set of numbers here, and we would say 2 minus 1 is 1, and then 1 minus 1 is 0, and we see that we are left with we're actually left with the number that we started with. So that tells us that this is correct, because we certainly can't go one more digit over, so we know that there's going to be a 1 in the 4's place. So what do we have left? Well, now we have to divide this number into this number, which we know is going to be 1. So 5 into 5, and remember, the number of zeros in front don't matter. It's the same number. So 5 into 5 goes 1 time. And here you have your answer. So you can test it by multiplying 5 times 5 and make sure you get 25, but you will. You already know that because we're working on a problem that we already know the answer to. So let's look at one more example. Okay, so let's suppose we have 3 into 10. Now we know this is going to have a remainder. Let's look at how this works when we try it out. So 3 into 10. Well, we know the answer isn't 1 because this would have to be 3. If the answer was 2, then this would be 6. And if the answer was 4, this would be 12, which is too high. So let's go ahead and put a 1 in the 2's place. And if we multiply this number times 2, we're just adding a 0 at the end. So it's going to become 0, 1, 1, 0. We can subtract. 0 minus 0 is 0. 1 minus 0 is 0. And 2 minus 1 is 1. And we're left with 4. Now, 3 goes into 4 one time, and if we multiply 1 times 3, we're going to get, of course, itself. And if we subtract, well, now we have to do some borrowing, or we can just be smart about it and know that 4 minus 3 is 1, and so we can just write out the 1. And you'll see that the answer is 3 with a remainder of 1. That's how you do it. Now, I recommend that you practice this on your own with problems that you know the answer to, so that you can see how it works out. So let's recap the method. When you are dividing a binary number into another binary number, you simply start by putting a 1 in the 1's place, see if that works, and then you try the 2's place and see if that works, and then the 4's place, and so on. And once you have reached a point where the number is too high, then you back off a bit and you try the number in the next place. So if you notice that a 1 in the 4's place will make too large of a number, then you know there isn't going to be a 1 in the 4's place, and you put a 1 in the 2's place, and then you keep doing that until you've solved the problem. So there you go. Now I know that division is more complex than addition, subtraction, and multiplication, but it's not all that difficult because you can always multiply the answer that you have to see if you have the right answer or not. So if you have any questions, feel free to post them, and remember that all of the lessons are available at highercomputingforeveryone.com.